Today I'll be sharing with you all the project on developing a demographically adaptive privacy preserving ocular disease diagnosis system on the edge using oneAPI. So this project is currently on process, but it builds on existing evidence from both medical AI and edge computing, and I'll walk you through our motivation, technical plan, and the outcomes we aim to achieve. In many rural and remote clinics, there are two pressing issues. First, there are a few very specialists available to interpret eye images. Secondly, the connectivity is super unreliable, and cloud-based AI systems can't always be trusted to deliver timely results. So the need is very clear. We require on-device, low-latency AI system that can triage patients quickly without relying on internet access. We propose to build eight class ocular disease classifier, expanding from a cataract, which is normal proof of concept. So the central challenge is making this work on low power devices while maintaining accuracy. So our solution is to leverage oneAPI, which provides an open and portable acceleration framework that can adapt to whatever hardware the clinic already has, whether that's a CPU, GPU, or NPUs. Why oneAPI? So from a technical standpoint, it gives us flexibility and performance at the same time. So the base toolkits offers compilers and profilers for building portable, reliable software. And we are leveraging all our deep neural network model with one DNN library, which gives us highly optimized deep learning primitives, which are essential for fast inference. With SQL or DP++, we can write single C++ code that runs across CPUs, GPUs, or other accelerators. So finally, for deployment, we plan to use OpenVINO runtime. So peer studies which we reviewed have shown the quantization can dramatically reduce model size and energy consumption, maintaining all the required matrices on the same time, which makes it ideal for edge devices. So in short, oneAPI provides the technical pathway to move from heavy usage model to a lightweight, portable, deployable model. So this is a proposed backend pipeline. So we start with data pre-processing, augmentation to strengthen our generalization. Next, we train the classifier with curated ocular disease dataset, which is around like 5 lakh patients so far we have collected from. And once we trained, we apply inference optimization using SQL and 1DNN, ensuring the model runs efficiently across devices. So the final step is deployment with OpenVINO, which makes the model lightweight enough to operate in real time, even on constrained edge hardware. So at this stage, the pipeline is a design proposal. Our next steps are to implement and benchmark it systematically. So in healthcare by itself, it is not enough just proposing the accuracy as a main metric. So we propose to evaluate the systems using matrices that matter in clinical settings. So first is latency, how quickly we can process the image. This is very crucial in real time. And second, throughput per watt, because devices in rural setting often run on limited power sources. Third is the F1 score, which balances precision and recall across all classes. And then the sensitivity or recall, which ensures we don't miss a patient with the disease. That's a non-negotiable thing in medical screening. And finally, specificity, which reduces false positive and prevents referral systems from being overloaded. So by tracking all these matrices, we ensure the model is not just technically sound, but clinically reliable and meaningful. So to summarize, we believe the whole system combined with oneAPI will give us faster inference and low power usage, making the system practical for edge deployment. And our next steps are to implement this pipeline, run experiments on both cloud and edge hardware, and then validate the approach in more diverse clinical environments. And this is very much a proposal, but it's grounded in existing evidence and optimized frameworks that give us confidence and in its feasibility. Yeah, to close our vision, to bring timely eye screening to undeserved populations by combining AI and edge-ready optimizations through oneAPI. And I believe this approach can reduce specialist workload, expand access to care, and set the foundation for scalable healthcare innovation. Thank you for your attention, and I look forward for your questions.